In this video, we will learn to solve some more exponential and logarithmic equations. Solve. Round to the nearest hundredth if needed. In this exponential equation, 3 to the x power equals 13. One thing I can do is kind of use a variation of the change of base formula that we used earlier. But what I can do is, just like other algebraic operations, as long as you do it to both sides, it is legal. So what I'm going to do is take the common log of both sides of the equation. So log of 3 to the x equals log of 13. Now, since this now is log of 3 to the power x, we know one of our log laws says we can pull the x out front. So I'm going to do that. X times log of 3 equals log of 13. So to solve for x, all I need to do is divide out the log of 3. So x equals, 13 in my calculator, log divided by 3 log equals, and I got 2.33. Now in this problem it says round to the nearest hundredth. We know that's 2 decimal places, so I can stop with that answer right there. 3 to the power of 2.33 comes out very close to 13. 4 to the power of 3y minus 1 equals 11. So I'm going to do the same thing. I'm going to take the log of both sides. I'm going to pull the power out front. We're going to divide by the log of 4. So I get 3y minus 1 equal to log of 11 divided by log of 4. Now to finish this equation out, I need to solve for y, so I would add 1 and then divide by 3. So add 1 to both sides, then divide by 3. So y equals, we're going to get 2 decimal places on it, but I'm going to do all this in my calculator at one time. So to punch that in, I will say 11 log divided by 4 log plus 1 equals, and then divided by 3 equals. So I actually got 0.91 as my solution, rounded to the nearest hundredth. E to the 2x equals 5. Now, in a problem where you have e, we know that natural log will get rid of the e. So if I take the natural log of both sides, we know that just leaves us 2x equal to the natural log of 5. Divide by 2. My exact answer would be natural log of 5 divided by 2. Now, we can approximate that to the nearest hundredth. So in my calculator, I'm going to do 5 ln, or natural log of 5, divided by 2 equals. And to the nearest hundredth, that would be 0.80. This is a different type of equation. Log of x plus log of x plus 2, or x plus 21, equals 2. Well, to solve this equation, first of all, on the left side, I could write that as one logarithm using log laws. Since it's been expanded out with 2 logarithms, the base is common, its base is 10, and it's been separated with addition, I could do it in multiplication instead. So log base 10 of x times x plus 21 equals 2. So actually, we know that 10 to the second power equals x times x plus 21. So 100 equals x squared plus 21x. So we have a quadratic equation to solve. x squared plus 21x minus 100 equals 0. So to try to factor that, two numbers that I can multiply together to make negative 100, but would add to be 21, that would be positive 25 and minus 4. So if you set those equal to 0, x would equal minus 25 and positive 4. Now, when you are solving a log equation, the argument can never be negative. So if I put negative 25 in here, I would get a negative number, and also here I would get a negative. The argument of a logarithm can never be a negative number, so throw that one away. And 4 would be okay. Log of 4 and log of 25, that would be okay. So the only solution for this equation we can have is the 4. All right, and in this problem, the natural log of 3t minus 4 minus natural log of t plus 1 equals natural log of 2. We know on the left side we can write that as one logarithm, natural log of 3t minus 4 over t plus 1 equal to the natural log of 2. Now, since we have natural log also on both sides of the equation, if this is true, then this argument must equal this argument. So my actual equation is 3t minus 4 over t plus 1 equals 2. Now, if you remember from earlier algebra classes, to solve this equation, I'm just going to multiply both sides by t plus 1. So we get 3t minus 4 equal to 2 times t plus 1. 3t minus 4 equals 2t plus 2. Subtract t from both sides. So I get t minus 4 equals 2. Add 4 to both sides. T equals 6.